Welcome in the arena. I'm Allyson Klein. We're coming to you from the OCP Summit in San Jose, California, and I have a fantastic guest lineup today. Banani Mohapatra, Senior Manager of Data Science at Walmart, is with us, along with Kartik Srinivasan, CMO of Cornelis. Welcome to the program, you two.
Thank you.
Thank you.
So, Banani, why don't you start? You are building AI systems at Walmart that serve millions of customers. Can we paint a picture of the scale you're operating at, and where do infrastructure challenges slow you down when you're operating at that scale? That's a big question.
Yeah, thanks for the question, Allyson. I really wanted to start with giving what I exactly do so that I'll fit in the answer to that entire thing, right? So currently I lead a product data science team, which is a global data science team. And our primary role and focus is to develop experimentation infrastructure and frameworks along with causal inferencing pipelines for millions of customers that comes to the Walmart, both from the physical space like in the stores and also in the digital space like app and web platforms. So the core of what we do is the experimentation infrastructure, right? And then since we're building features on such a large scale, so it becomes very important to have infrastructure that scales automatically, helps us in doing real-time decisioning, has a feedback loop to do real-time inferencing. We also do a lot of automated metric computing, and these all are the features that we usually do, and that's where infrastructure becomes very important for us in our day-to-day work. And the challenges, as I said, since there are so many functionalities that were required, so we need to have very, very cost-efficient and optimized system to help us build all these systems and these features holistically together. So, yeah.
Now, I know that your research is covered, and you just talked about it, causal inference, generative AI, and now agentic AI. We recently talked to another scientist from Walmart about the fact that you are starting to deploy multi-agent systems.
Yeah.
Give me some perspective, and as we make that transition, how do infrastructure requirements change, and what is the cost if things sit idle?
Yes. So to understand that, we have to understand the evolution, right? So initially, if you go 5-6 years back, the complications of the users were not that much. We were in the traditional AI phase. We were building probably more deterministic and predictive models, right? It was a very centralized system. We had one model. We used to deploy it. We used to create trigger systems out of it. But now that we have moved into a more artificial intelligence and multi-agent structure, what it means is we are now creating autonomous agents which can take the decision almost in the real time. But what each of the agent has their own memory requirement, infrastructure requirement, and a feedback loop necessary. Let's say take for an example. So like one agent does like pricing promotion predictions. One agent does like inventory or sort of resource allocation predictions. One agent does the pricing, and all of these has to be done almost in the fraction of milliseconds for us to give the right exposure and the experience to our end customer. So in this situation, we need an infrastructure that will help us orchestrate these collaboration into a more autonomous state, right? So for that, we need very cost efficient and scalable systems. And for example, we deal with billions of data. My expectation for the infrastructure is to, scale it accordingly. Let's say, for example, there might be a situation where the system is idle and we are not dealing with a lot of stuff. But then there might be situations where we are like holiday time frame where we lead with billions of interactions. So the system has to scale up and down depending on the requirement.
Now, Kartik, I know that Cornelis has argued that the network really serves as the Achilles heel of AI infrastructure right now. Can you think about what Banani has just proposed, and are you seeing this within other clients that you're talking to?
Absolutely, yeah. So before I answer that, let me also go ahead and introduce Cornelis, because we're slightly less well-known than Walmart. We are a startup that is maniacally focused on high-performance scale-out networks, and this is the backbone of performance acceleration for the world of AI that we live in. And to go back to your question, and Banani's comments are completely aligned with the way we see the industry as well. We see that the value of data decays over time. So the point that Banani was making about all of the inferencing applications with agentic AI right now, the time to response is extremely critical of a metric. And if you look at the modern data center with AI being the focus or the primary workload and all these XPUs that power the compute for it, the efficiency challenge that these XPUs face today is they are sitting idle for roughly about 50% of the time. And a good component of the reason why those XPUs are sitting idle is because of network congestion. The data is not being fed to these XPUs in a hurry. So when these XPUs sit idle, it's a criminal waste of your investment and your money investment and your power investment, your energy investment. And that's why Cornelis is coming in and saying that we can fix this inefficiency, the starvation of these XPUs from the network side by providing the most efficient and congestion-free and lossless network, so that the primary objective of all of these modern data centers is to keep your XPUs fed. And that's what we are trying to promote, so that the final user experience when it comes to these inference applications, or maybe the experience of the training time to completion, is optimum.
Now, Banani, when you think about that, if you could put some perspective around it, when running real-time inference or experimentation, how does network variability affect your application performance? And how does network performance impact your speed of getting new features into production?
Yes. So thanks for the question, Allyson. This is a real great thing, right? So again, going back to what we exactly do. So we do a lot of feature releases over the entire year. And we deal with a lot of interaction data from the users, which could be all this. For example, let's say click event. If somebody user comes to the platform, they see something, interact with it, search for it, and then eventually go and purchase. All of these entire life cycle are individual events. So on a in an organic time frame too, we deal with billions and billions of rows, and that event becomes 2x or 3x when it comes to the holidays, right? So this space is very dynamic, and it has a very event driven. So in order to help us scale up or scale down, so network constraints are very important. As I said, there has to be some kind of automated system that determines when the system could be idle versus when the system should allocate multiple resources in order to make it more efficient, optimized, and this helps us build more reliable systems. And for an example, we launch around 100 plus features in a year to our end users, and that impacts millions of customers. So that's the scale that overall Walmart ecosystem operates. So for us, dynamicity, adaptability, and optimization goes hand in hand.
Kartik, when you think about idle time, how do you translate that into lost economic opportunity?
Oh, this is a criminal waste. If you look at the economics of a purchase of a data center from a capex standpoint, and the energy which is needed to power the data center, as well as to have thermal cooling and power dissipation of the equipment in there, it's a criminal waste when the primary investment of these XPUs is sitting idle. Essentially what happens in that situation is that you're not getting your data getting analyzed, and like I said, value of this data decays over time, especially for inferencing applications. But time to completion for your training models is also extremely critical. So to avoid these XPUs from sitting idle, there has been a tremendous amount of investment that is being made across multiple fronts, from storage, from software models, and of course from where we come from, where we see this having the maximum impact is from the network side. We provide the network that allows for a congestion-free, maximum performance, lossless delivery of the data to these XPUs to prevent them from sitting idle.
Utilization is obviously part of total cost of ownership.
Yeah.
But can you walk us through how you and your team see total cost of ownership playing out as you're deploying these applications?
Yes. So total cost of ownership is like collective effort. My team particularly focuses on building the model and deploying the model, and then we also consume the model on a real-time inferencing data ecosystem. So it becomes very important for us to keep in check how do we utilize the resources more effectively, right? And on an average, we deploy close to, let's say, 50 plus models in the production over a month or a quarter or a year basis. And the model complexity also determines the overall cost. Sometimes the model just impacts as a set of users, sometimes the model impacts like almost all the ecosystem, the entire user journey. So this variability has to be taken into account while upfront determining how we can manage the cost, and then going back to the fact that there has to be some reliability and differentiation of what infrastructure should be dedicated to which type of models. So yeah.
So I love this conversation because we've got, in one stance, Cornelis Networks is working with a wide variety of companies, talking to them about their AI implementations. And Banani, you at Walmart, one of the leading adopters of AI in advanced applications, what advice would each of you give to an organization that is building out their AI infrastructure today and attacking delivery of AI within the enterprise? Banani, take this from the practitioner side, and Kartik from the infrastructure innovation side, and give us your perspectives. Banani, why don't you go first?
Yes, for sure. So thank you. And I would highlight on three important parts. So infrastructure always comes as a later part of the conversation where we have to move it as a first part of the conversation. When we are building, we first focus on the business use case and then go into model deployment and then development and then think about, okay, then maybe we can scale it to it. Let's bring that discussion at the start of the entire process and understand if you have to scale up the solution to millions of users, how can we think about infrastructure as a key driver? The second part is bringing data quality as a discussion into the infrastructure itself. So it's not about only data storage or computing it, how reliably and correctly we are storing the data, because that determines the entire process of our execution, right? And when we are selling out features, scaling out features to our end users, it's very critical that we have the right data set that informs our decision. And the third part is all about governance and reproducibility and reliability. So these all the different facets should be invoked when we are having an infrastructure decision, because that becomes the core functionality of deploying and maintaining any of the feature that goes to our end user in Walmart.
Kartik, that was a good answer, and now you've got to give the counter answer about the
I got to follow
delivery.
that act.
Yeah, exactly.
I can tell you that the world of AI that we live in, I feel like we're at the tip of the iceberg. We haven't even started exploring and leveraging the real benefits of what this technology and the workload can provide for betterment of humanity. I just feel like we're at the cusp of something extremely extraordinary here. So from an infrastructure standpoint, from Cornelis, we look at it as an application performance, as a benefit to the final consumer. With that kind of focus, my recommendation to anybody who is doing data center architecture right now is to think about performance, think about scale, and think about openness. Because you have to figure out how you can eke out the maximum performance from the infrastructure that you're investing in, build it for scale. Because we're looking at solving highly complex problems, whether it's in the world of AI training, fine-tuning, or inferencing. These are complex technology problems that require a lot of infrastructure investments. You've got to think about scale and then think about openness, because that's what brings in the concept of easy deployment, easy manageability, easy fleet management. So that level of openness, when you have it, just becomes much easier for data centers to operate and actually have a manageability that is easy.
Well, thank you both for being on Tech Arena today. It's so great to catch up with both of you. One final question for each one of you. How can folks continue the conversation with you as they start on their path to AI adoption?
Awesome. So I'm very active on LinkedIn. I do have a active Substack where I create content around experimentation, basic, advanced and stuff. And mostly reachable and accessible through LinkedIn.
Yeah, for me, it's very simple. Just go to cornelisnetworks.com and just contact us using our website.
Well, thank you so much for spending part of your day on the Tech Arena.
Oh, awesome. Thank you, Allyson.
Thank you.